All right, we are going to begin doing the problem set for the level 1 torque calculation problems. Just a reminder, the equations we're probably going to want to use, or the tools we're going to use, and I discussed this in a previous video about like what your toolkit will be, is that torque is equal to the perpendicular force applied on a lever times the distance or the position vector that force is away from the pivot point or the fulcrum of that lever. So if we take a look at this problem, we have a lever here. That's this bar in this region. We have a pivot point. This is where this lever can rotate around. You're provided with a force, and we know that because it's in newtons. And we're provided a distance, which we know is because it's in meters. The thing that we're going to have to do by the time when we finish calculating these problems is to determine the direction of the torque vector, and it's either going to be positive or it's going to be negative, and that just communicates which way is it turning. So if it's going counterclockwise, then it's going to be positive torque, so counterclockwise. And if the vector applied on it is pushing it to turn it clockwise, then we're going to have a negative torque. And this little symbol we use again is called tau, and we use it because the other versions of the English alphabet were taken. So let's begin. Number one, it asks us to calculate the torque on the lever. So we have a lever, and we have the two things that we need for it. They've provided, so we want to find torque, which is equal to the perpendicular force times the position vector or distance that force is from the fulcrum. Now, our perpendicular force in this case, that's what a little subscript means, perpendicular, is equal to 40 newtons. The position vector, or the distance it is from the pivot point, is 1.5 meters. So we can do a substitution, and we can put that 40 newtons times 1.5 meters is equal to our torque, and I know that 40 times 1.5 is 60. So I have 60 Newton meters. And the last thing I need to do is just determine which way is this going to turn it and assign some type of sign to it, so either a positive or a negative. So this force, which is being applied going up on the right, force it to turn in the counterclockwise direction. So the reverse as the arms on a clock go. And if it's counterclockwise, and I forgot to put the clockwise right here, if it's counterclockwise, then we have positive torque. So this is going to be a positive value right there. So that is problem number one. Thank you very much.